Hi, boys and girls. Today we're going to be reviewing two-step equations. Based on the results of your pretest, I think it's important that I go back over these. I'm not sure how well they were covered last year, and you guys seem to have some misunderstandings. So if you have not already, feel free to go over to Google Classroom, and if you have a printer and you have the capability to print a PDF, you can print this worksheet and make it easier for you to follow along, but you can also just write the problems down and do the work. No, I do not have the webcam on today. I've been working out all day. I worked in the garden and I have no makeup on. I am not turning the camera on. I'm going to be one of those people, you know, like in the Zoom meeting where you're showing me your ceiling. Yeah, that's me today. And I apologize in advance for any distracting noises. I do have 2 dogs. All right, so this is your review of two-step equations. I hope that you have a paper, pencil, and a calculator. Why is that off? It should not be off. Okay, so when we're solving two-step equations, these are our 2 steps. The first thing we always want to do is add or subtract to isolate the variable term. The second step is always to multiply or divide to isolate the variable itself. All right, so here are the first 4 examples on the worksheet. Number 1, the first step is to isolate the variable term. Well, here's the variable term right here, this negative 5m. Keep in mind that the sign in front of a number goes with the number. The negative belongs to the 5m, not the 9. The 9 is positive. If it were negative, it would have a negative sign out here. In order to isolate the variable term, we always have to add or subtract to remove the other random number. So this is a positive 9, and we will get rid of it by subtracting 9 from both sides. That gives us negative 5m on the left-hand side of the equal sign, and on the right-hand side of the equal sign, we have 25. Second step is always to multiply or divide to isolate the variable. Here we have negative 5 being multiplied with m, so we're going to divide by negative 5. Divide both sides by negative 5. Those cancel, and we get that m is equal to negative 5. Okay. Sometimes the variable will be on the right-hand side of the equal sign. Perfectly fine, no problem. Here is the variable term. We will need to add or subtract to isolate this term, which means we're going to have to get rid of this number. You always want to get rid of the number that is on the same side with the variable term. So that is a negative 7 or a minus 7, so we're going to add 7 to both sides. That gives me negative 10 on the left-hand side is equal to negative 5b. Now the second step is always to multiply or divide to isolate the variable. This is negative 5 times b, so we want to divide by negative 5. We divide both sides by negative 5. Negative 10 divided by negative 5 is positive 2, which is what b is equal to. And I don't care if the b is on the right or the left. You can do it either way you want. Here's another example, the variable term being on the right. Okay, 2b is our variable term. It happens to be on the right. That's totally fine. We want to add or subtract to get the variable term alone. So we need to get rid of the number that is on the same side with the variable term. We need to get rid of this plus 1. We do that by adding 1 to both sides. That will give us 28 is equal to 2b. Step 2, divide or multiply both sides to isolate the variable. Because this is 2 times b, we need to divide. 28 divided by 2 is 14. And 2 divided by 2 is 1, so we have b. And the last example on this page, here is our variable term. We need to add or subtract to isolate the variable term. So we will add 8 to both sides. That gives us negative 6v is equal to negative 48. Now we multiply or divide to isolate the variable. We're going to divide both sides by negative 6. And these will cancel, leaving us with v equal to positive 7, because a negative divided by a negative is a positive. Okay. Moving on. Here is our variable term. We will need to add or subtract, which means we're going to add 6 to both sides. That gives me 90 is equal to 9n. And now to get n by itself, my second step is to divide both sides by 9. Those cancel, and I get n is equal to 10. My last example of this form, here's my variable term, the 3n. So I need to add or subtract to get it alone. So I'm going to add 3 to both sides. That gives me 3n is equal to negative 18. My final step will then be to divide both sides by 3 to get n by itself, and I get n is negative 6. Now, if you don't have the worksheet, I hope you're writing these problems down. All right, now these are a different kind. In this case, the variable is being divided by a number. So our second step, which has been divide up until now, is now going to be multiply. So let me show you what I mean. Here is my variable term. I add or subtract to get the variable term alone. So I need to get rid of the plus 1. That gives me x over 10 is equal to 2. Now here's where it differs. Because this is x divided by 10, I will have to multiply both sides by 10. Multiply both sides by 10. 10 divided by 10 is 1, which gives me just x, and 2 times 10 is 20. I apologize for the noise. My Chihuahua has a restricted trachea, so she coughs constantly. It's something I've kind of gotten used to, but I'm sure you're all thinking my dog has the corona. She doesn't. It's a chronic cough, but she can be annoying. All right, another example of that type. Here is our variable term. We want to add or subtract to get the variable term alone, so we need to get rid of this minus 9, and we do that by adding 9 to both sides. And I didn't mean to click that. Negative 8 plus 9 is 1. And we just have x over 16 on the right. Now this is x divided by 16. So our last step, or our second step, would be to multiply both sides by 16. 16 times 1 is 16. And these cancel, leaving us with just x. And so we have x is equal to 16. Okay. Sometimes she barks for an encore. If she starts barking, you'll have to pause the video because that means she wants out. Again, we have a variable term here that is a quotient. Okay, so this is our variable term. We need to get it alone. And so in order to do that, we will add 2 to both sides. Yep, she's about to do her barking thing. She was a rescue. And we couldn't figure out for a long time why people would want to get rid of such a beautiful little dog. She's gorgeous, little long hair white Chihuahua. And you're about to find out why those people got rid of her, because she's about to bark shrilly because she wants out. This is x divided by 4. The opposite of divide is multiply. So we multiply both sides of the equation by 4. Those 4's cancel, and that gives us x is equal to 8. The last example of this type, here's our variable term. We need to add or subtract to get rid of this number. We want to get our variable term alone. So we will get rid of it by subtracting 6 from both sides. That gives me 6 is equal to k divided by 3. Now this is k divided by 3. The opposite of divide is multiply. So we will multiply both sides by 3. And we'll have just k on this side, and over here we have 18. So that's how you solve regular, straightforward two-step equations. Oh, there she goes. I told you she was going to do it. I knew it was coming. All right, hang on a second. I'll let the pain in the butt Chihuahua out. Okay, I gave her a pepperoni. Hopefully she'll be quiet now and leave me alone. Okay, these are an oddball. These are actually two-step equations, but they're solved in reverse order, okay? The reason being that we have this expression with the variable and the numerator, and before we can do anything to solve that, we have to get rid of the denominator. So our first step is not adding or subtracting in this case. In this case, our first step is going to be to multiply both sides by whatever number is in that denominator. What that does is it enables us to get rid of this hideous looking fraction we have and just have 6 plus a on the right. On the left, I have 4 times negative 3, which is negative 12. Now my second step would be to add or subtract to finally isolate the variable a. Well, this is a positive 6, so I'm going to subtract 6 from both sides. And that gives me that a is equal to negative 18. I know, that's pretty cool. I'll show you it again. Don't worry. These are the oddities when you have an expression in a fraction like this. These are the oddballs and the steps are reversed, okay? Your first step is to multiply or divide to isolate the variable expression. So because this is negative 9 plus m divided by 14, we will have to do the opposite. We will multiply by 14 to get rid of that. These 14s cancel, giving me negative 9 plus m on the left-hand side of the equal sign and negative 14 on the right. Now my second step, here's my variable term. I have to add or subtract to get rid of this negative 9. To get rid of negative 9, we add 9 to both sides. Okay, and that gives us just m on the left-hand side, and negative 14 plus 9 is negative 5 on the right-hand side. So m is equal to negative 5. Don't panic. I know there are fractions and mixed numbers on this page. It's okay. You're in good hands. I can do these. All right. These first two are very similar to the ones we did on the page before, so nothing scary happening there. Just forget about the fact that this is number 13, okay? Same thing, we have a variable expression that we need to free from this fraction. In order to do that, we multiply both sides by the denominator, 6. Multiply this side by 6. These 6's will cancel, leaving us with just negative 1 plus r on the left, and negative 1 times 6 is negative 6 on the right. Now here's our variable term. In order to get it by itself, we need to get rid of this negative 1, and we do that by adding 1 to both sides. We arrive at our final answer, r is equal to negative 5. Okay. And the last example of this type, again, to free this variable expression, we need to get rid of this 2. This is n plus 6 divided by 2, so our first step is to multiply both sides by 2. 2 times 8 is 16, and these 2's cancel, giving me n plus 6. Okay. Now here's my variable term, n. I need to get it alone, but it has a plus 6 keeping it company. So I'm going to subtract 6 from both sides, and that gives me 10 equals n. And that's the end of the fun problems. Now we get to some more challenging ones. You're also going to be faced with two-step equations that involve fractions and decimals. And these are a little more challenging, but you're going to want to rely on your TI-30 to do these. On the other hand, I'm kind of old school and I enjoy doing fraction problems, so it's kind of fun for me. The steps are the same though, all right? This is your variable term right here. Just like the beginning problems, we have a number being multiplied with our variable. That's our variable term. To get it alone, we're going to add or subtract to get rid of this number. This is a negative 5/4, so we're going to add 5/4 to both sides of this equation. Well, this positive 5/4 is equal to positive 1 1/4, and that's what I'm thinking in my head when I'm doing this problem. If I add positive 1 1/4 to negative 3 1/4, I get negative 2. You could have just put that in a calculator and you would have arrived at the same answer. Negative 5/4 and positive 5/4 cancel, and we have just 2x on the right. And then our final step is to divide to get x by itself. So we divide both sides by 2, and we arrive at our solution, x is equal to negative 1. Again, it doesn't matter which side of the equal sign you put the x. This problem is very similar. This is our variable term here, this negative 9/5 n. To get it alone, we'll first need to subtract 2 from both sides. Well, if you subtract 2 from 2 9/10, you have just 9/10 left over. And on the right, we have negative 9/5 times n. Well, to get negative 9/5 away from that n, we have to, this is being multiplied with n, we're going to divide to get rid of that. We'll divide both sides by negative 9/5. Here's where it gets fun. You can get a calculator if you don't think fractions are as fun as I do, but dividing by negative 9/5 is the same as multiplying by 5/9, negative 5/9. And here's what's cool. These 9s are going to cancel. This 5 becomes a 1 and the 10 becomes a 2. And that means that n is actually equal to negative 1/2. Like I said, if you're not enjoying the challenge, you could totally do this in a calculator. Just do 9/10 divided by negative 9/5 and it will give you the same answer. I just couldn't resist. These are my last examples here. Let me move them over just a smidge. These are why I brought out the calculator, because while I love doing fractions the old-fashioned way, I don't love doing decimals the old-fashioned way. So I will be using the calculator for these. Same type of problems, two-step equations. The only difference is I have mixed in decimals. All right, we have our variable term here, negative 6.3m. We need to get it alone by getting rid of this number right here. That's a positive 6 1/5. Or 6.5, so we're going to subtract 6.5 from both sides. Oh, now that's my other dog. Her name is Abby, and she's very excited right now because she sees something in the backyard. And she does this growly, talky thing because she wants somebody to let her out so she can go bark at some random cat or something. Don't pay any attention to her. Okay, while I was rambling on, I subtracted 6.5 from 73.91, giving me 67.41 equals negative 6.3m. And then our last or second step is to divide both sides by the number in front of the variable. So negative 6.3. These cancel out, leaving us just m, and we're going to rely on the calculator for this step. That number, 67.41, divided by 6.3, you would have probably made it negative. It's okay, I just know it's going to be negative. And I have negative 10.7 as my solution. And when we're dealing with decimals, sometimes the answer is not necessarily a whole number. So you can expect that. Here we have one of these oddball problems. This is the one where there's an expression being trapped in a fraction. So our first step is to multiply both sides by 10. A cool thing happens here though. Watch, 10 times 0.6 is 6. How nice is that? And that gives us b plus 3.7 is equal to 6. Now our second step, since b is right here, is to get rid of this plus 3.7. We can do that by subtracting 3.7 from both sides. And actually that gives us 2.3 for 6. No calculator needed. Unless I'm wrong, in which case someone will tell me. I think I'm right. All right, you could have put it in the calculator though, just 6 minus 3.7. This one, oh boy, look at these numbers are just getting uglier and uglier, aren't they? It's a good thing this is the end because I don't know how much more of this you could take. Here's our variable term. We need to get rid of this number, so we will add or subtract. Because it's positive, we're going to subtract 7.3 from both sides. All right, on the left, we only have negative 4.8x. On the right, we have these two are both negative, so this is going to make a bigger negative. So really what it is, it's going to be negative 21.98 plus 7.3 equals 29.28. And it's negative because it was a negative plus a negative, 29.28. And then our last step will be to divide both sides by negative 4.8. Negative 4.8, those cancel. And divided by 4.8 equals, oh, look how nicely that turned out, 6.1. And because it was a negative divided by a negative, 6.1 is positive. Okay. It's so sad that we've come to the end here. Our last example, we have a variable being divided by a number. So this is our variable term. We need to isolate that by getting rid of this number. This is minus 4.1. So we're going to add 4.1 to both sides. I bet I can do this one in my head. 7.48 on the left equals n divided by 2.5. Okay. And now this is n divided by 2.5. So to solve this, we need to just multiply both sides by 2.5. That I can't do in my head. These cancel. And all we have to do now to finish off this lesson is to multiply these two numbers together. We have 2.5 times 7.48. And our answer is 18.7 is n. So these were several examples of how to solve two-step equations. From here, you will need to go to McGraw-Hill and complete your solving two-step equations practice. But I think we'll leave that for tomorrow because this was pretty grueling, and I think this is a whole day's worth of work. So how about tomorrow you do the practice, and today, just go over and do the secret word. Coronavirus explained in craft terms. You and 9 friends are crafting. One is using glitter. How many projects have glitter? Well, glitter's the secret word, and the joke here is that glitter gets everywhere. Custodians hate glitter. That's their most hated thing that teachers use, because if we use it, it's all over the room, and it takes them forever to get it out of the room. They hate glitter. That's all I have for you for today. Thank you for watching. Make sure you enter the secret word of McGraw-Hill, and tomorrow we'll tackle the practice. Have a good one.